Hello, everyone. Namaste and good evening to everyone. Today, we are doing the Math Focus webinar series for 2022, and this is our sixth episode of the webinar. Today we have the presentation by Harsh Bahadur Chand and Siddharth Rajak, but unfortunately Harsh sir is not will not be able to present today because of some personal reason. So we'll have Siddharth Rajak as our first presenter, and I would like to welcome you all in this webinar. This is Rosni Rajbangsi from his team department and welcome you all. So, Siddhartha sir, would you like to introduce yourself and start the presentation?
Yes, sure, ma'am. Thank you so much.
Siddhartha sir,
Uh,
yes, please go ahead, sir.
Thank you, Roshni, ma'am. So I think I'm audible. Very good evening
Yes.
to everyone present today. So I'd like to first of all share my slide and introduce myself. Meanwhile, okay. So please let me know once my slide is visible.
Okay.
Okay. So I think my slide is on air now.
Yes, please go ahead, sir.
Okay. Thank you so much, ma'am. So a very good evening to all, one and all present here. So I am the presenter for the day, and my name is Siddhartha Razak. So today I'm going to talk about mathematics through mental mathematics approach. So before starting my presentation, I'd like to introduce a little about myself. So I am the scholar of M.Ed in Mathematics Education here at Kathmandu University. I am working as a secondary mathematics teacher in the Kathmandu Vidyalaya school, and I'm also a faculty member of Kathmandu A-Level Academy. I teach pure mathematics over there. So without further ado, I'd like to go straight into my presentation. So this is the synopsis of my presentation. Firstly, today I'm going to talk about the mental mathematics approaches to find out squares of different kind of numbers. Secondly, I'm going to talk about this how to find out the square root of 4 to 5 digit perfect square numbers. And Number three, I'm going to talk about how to find out the cubes of numbers by using the mental mathematics approach. And lastly, I'm going to conclude by talking about how to find the cube root of perfect cube numbers. So, going into the main slide now. I'd like to formally start my presentation. So this is the first activity that I have, or the first approach where we can find out squares of numbers between 25 and 75 by the mental mathematics approach without actually finding or multiplying the squares of numbers. So this is the first slide where I'm going to talk about how we can find out the square of numbers between 25 and 75 without actually multiplying. So these are the steps that are involved. First of all, let us choose one number between 25 and 75. Let's say 41 for now. For this, to perform this activity with ease, we if we know the squares of 1 to at least 25, then we will be able to do this with more flexibility. So even if we don't know that, we can always figure ideas out on how to find squares of numbers without actually knowing the squares of other numbers. So let's go to the first step. I choose a number, let's say 41 for now. The first step is choosing a number of which we have to find the square of. I choose 41 for now. The step two is actually subtracting 25 from that number. So my number was 41. I subtract 25 from the number, and I get the result as 16, 1, 6, 16, which is coded in green. I think you can see in your screens as well. So 41 minus 25. First of all, you need to subtract 25 from the number that you are trying to find the square of. So it's 41 minus 25, which is 16. And in the third step, sorry, you got to subtract 50 from the number. But when you do that, make sure you find the square of the number that comes. For example, in the second step, you can see we subtracted 25 and wrote down 16 as it is. But now, when we subtract 50 from the number, that is 41 minus 50 is minus 9 or negative 9. So now you need to write down the square of minus 9, and the square of minus 9 is 81, which is quoted in blue in the screen. So to find out the square of 41, we can write down the numbers from starting from green and ending with blue. So it is 1681. I think you can check on your calculators as well. The square of 41 should be 1681. So this technique can be used to find out the squares of numbers between 25 and 75. Now, using the mental mathematics approach, the students or whomever we want to inculcate this idea with, we can just try to make them subtract 25 from the given number and then 50 from the given number. But whenever we subtract 50, whatever number comes up, we just need to square that number, and then place it after the number that we got while subtracting 25 from. So it is 1, 6, 8, and 1. So likewise, you can find the square of any numbers between 25 and 75. So moving on to the second activity, or let's say the second thing on my slide. So to find out the squares of numbers between 75 and 25. Previously, I talked about how to find squares of numbers between 25 and 75. But now, how can we find out the square of numbers between 75 and 125? So again, let's choose a number. Let's say 106 for now. So let us take a number 106. It's a three-digit number, and we need to find the square of this. So when students tend to multiply in smaller grades, students usually tend to take up a lot of time while finding out the squares of these big numbers. So now, whenever we have to do this by mental calculation, it is marvelously easy because the technique of mental mathematics is such. So in the second step, after choosing the number, we need to subtract 100 from the number, and whatever number comes, we need to add that to the original number. For example, 106 is the original number. 106 minus 100 is 6, and you need to add 6 to the original number, that is the number that we are trying to square on. So 6 plus 106 is 112, so which is quoted in green. So first step is you need to subtract 100 from the number, or when you can even say whichever number you take, how much that number is greater than 100, you need to add that number to itself. So 106 is 6 greater than 100, so you need to add 6 to 106, so it becomes 112. This is the first step. And in the next step, whatever number you subtracted from 100, from the number to get 200 to get that number. For example, you subtracted 100 from the number, and whatever number you got, for example, 106 minus 100 was 6, you got number 6 as your result. So whatever number you got, you just square that number. So the square of 6 is 36, which is quoted in blue on your screen. So now these two numbers, when kept together from the left to right, from green to blue, so 1, 1, 2, 3, 6 is the square of 106. This is a way to find out the squares of numbers between 75 and 125. This number actually was greater than 100, so we used 6. We added 6 to it because it was 6 greater than 100. If we are to find out numbers which are lesser than 100 between 75 and 125, for example, let's say 95, then we need to subtract 5 from 95 because it is 5 lesser than 100. So whenever we do for numbers which are between 75 and 100, let's say, we need to subtract, and for numbers which are greater than 100 to 125, we need to add. So 106 was our original number. It was 6 more than 100, so we added 6. For example, if we took the number 95, it is 5 less than 100, so we would have subtracted 5 from 95, which would be 90. So likewise, we will be able to find out the square of numbers between 75 and 25. Okay, so this is the technique to find out numbers the square of numbers between 75 and 125. So moving on to the third activity of the slide that I have. So what if the number is 125 and above? So even if we know the squares of numbers from 25 to 75 and 75 to 25, 75 to 125, sorry, we can find out the squares of numbers even higher than that. So we can we can follow these steps to do so. So the step number one is, first of all, taking a number, let's say 173 for now. So I choose 173. So I need to find the square of 173. You'll use the same technique you used in the previous slide. You know that 173 is 73 more than 100. So you basically add 73 to 173, which becomes 246, which is coded in green in the screen, right? So in step number three, what you do is whatever number you added to 173, that was actually 73, right? So 73 plus 173 became 246. Whatever number you added is to be squared now. So the square of 73 can be easily found out by the help of my first slide, where we found out the squares of numbers between 25 and 75, right? So by that technique, you find out the square of 73, and the square of 73 is 5329. But as we placed numbers in the previous two slides, the number should be 2465329, but that will be a very big number. It will be a 7-digit number, right? So if we square 173, I'm pretty sure it's not going to be a 7-digit number. So now, in order to get our answer correctly, we only take two digits from the number quoted in blue, the last two digits. 29 is the number we keep, and that 53, which is excess over there, needs to be added on the added on to the it's to be carried over to 246, and 246 plus 53 becomes 299, right? So the number that we will get is 299 in the from the first addition, and 29 from the numbers that we retained. So that number is 29929. So the squares of numbers can be found out like this. But for that, the students should be channelized in such a way that they understand why we did this. So a three-digit number, a three-digit number will have square. Whose If we try to find the square of a three-digit number, I'm pretty sure we're not going to get a five-digit number which is more than 5 digits until let's say 300 something, right? 300 something, because 300 times 300 should be 9 and 4 zeros at the back. So that'll be a 5-digit number. So we'll have to move to 320 and above to get any numbers which are 6 digits and more. The squares are 6 digits and more. So that kind of understanding should be fed into the students whenever we do this, because students won't understand the logic behind it. So like this way, we can find out the squares of numbers from different squares of different kind of numbers by using the mental mathematics approach. So okay, so if you all have any kind of queries for this, please you can put it in the chat box. I will just scan this chat box a little quickly. Okay, so if you all have any questions, please feel free to write them in the chat. Yes,
Yes,
ma'am.
we do have a hand raised by Monica ma'am. So Monica Detkota ma'am, are you there? Hello. So, Siddhartha sir, thank you very much for your very um, elaborative presentation. It was very interesting to see how we can find the squares of the number. So, we would like to have a question answer with like everyone who has question for Siddhartha sir can put the question in the chat box, or you can directly ask a question. And I do see Monica ma'am raising her hand, but Monica ma'am, are you there? Otherwise, anyone else who has question can ask.
Okay, ma'am. I think and we can take the question and answers at the last as well. I have
Okay.
still a few slides to go.
Oh, you do
So
have. Okay, please go ahead
uh,
then.
okay, thank you, ma'am. So this was the end of the squares section. Okay, so I have the square root, cube, and cube root section as well. So let's move to that and let's take the questions at the end. So these three slides were actually focused on how to find the squares of numbers. So now we can go to the second part of the presentation where we try to find out the square root of any four-digit perfect square number. So first of all, we have to take a number which is a perfect square. Let's say 2209 for now. So a four-digit number which is a perfect square. So if I have to find the square root of this number 2209 for now, so I'll have to make pairs from the unit place. So from the rightmost side of the number, I'll make pairs. So 09 is one pair and 22 is another pair. So from this, we need to just look at this figure that I've just shown on my screen. One square is four, one square is one, two square is four, three square is nine, and so on. You can see squares up to number 10. So if you look at the unit place of the squares, you will be able to find there's a small connection in there. So one square is actually one, and nine square also is 81, which ends up with one, right? So likewise, the two square is four, and eight square is again 64, which ends with four. And three square is nine, seven square is 49, that also ends with nine. And the same applies for four square and six square, which is 16 and 36, which ends up with 36. So which ends with six. And 5 square is 25, right? And 10 square is 100. So there are no numbers over there on the figure that I've shown, which ends with 2, 3, 7, and 8. So we can even inculcate this knowledge into the students that no number ending with 2, 3, 7, and 8 can be a perfect square number. So after this, the students will also have some idea about perfect square numbers and which numbers cannot absolutely be a perfect square. So after we make the pairs, okay, let's come back to the point. So after we make pairs from the left hand side, that is 09 is one pair and 2 is another pair. So just look at the rightmost pair, which is 09. So numbers that end with 9, okay, has to be a square of a number whose unit place is either 3 or 7. So you'll have to understand, if you square 3, it'll be 9. If you square 7, it'll be 49. So whenever you square numbers ending with 3 or 7, then only you are going to get 9 at the end. So the last digit of the number 2209 is actually 9. So the last digit of the square root is either 3 or 7. You have to understand that, which is quoted in purple in the figure that I've just shown. So now after this, you need to find out whether it's 3 or 7. We have to be sure of that, right? So we have to look at the squares. For that, we need the first two digits. The first two digits is actually 22, right? So 22 is the number which is paired which is the other pair actually. So that 22 actually lies between 16 and 25 if you look at the squares column. So in the squares column, 22 will lie between 16 and 25. It'll be somewhere in between 16 and 25. So if the number is between 16 and 25, we have to choose the smaller number, which is always 16, right? 16 is the smaller number amongst 16 and 25. So 16 and 25, 22 lies between 16 and 25. So you always choose 16 and you take the square root of that, which is 4, right? So we can be sure that the square root, that the first digit of the square root will be 4. So our number is either going to be 43 or 44, 47, right? The first digit is 4 for sure, right? It's 4 for sure. And the last digit is 3 or 4, right? So it's either 43 or 47. Now we have to be sure if it's 43 or it's 47, right? So for that, you take the number, okay? We take the number 4, that is the first digit of our square root. So you multiply that 4 with a number which is 1 greater than it. So a number which is 1 greater than 4 is 5, and multiply 4 and 5. Okay, the number 5 is to be multiplied with 4. The 4 is the first digit of our square root. You multiply that number with one greater number than that. So 4 into 5. 4 into 5 is 20. Now you need to look at the pair that we made. It's 22, right? Is 22 greater or 20 greater? Okay, so you have to realize that. So 20 is lesser than 22. So 22 is greater. Since 22 is greater, you have to choose the greater number. So our answer could have either been 43 or 47. So you have to choose 47 because 2 that is 2 of our pair, that is 22, is greater than 4 into 5, which is actually the technique that we used, right? So 22 is greater, so we choose the bigger number, which is 47. For example, if this number was a little different, let's say if the number was 1849. Okay, if 1849 was the number, we would still do this for the unit place because it will be either 3 or 7 at the unit place, right? And the first two digits, the first and the other pair would be 1, 8, 18. So that 18, whenever we multiply 4 with 5, we are going to get 20, right? But 18 would be smaller. So that time we would choose the smaller number, which is 43. So like this, we will be able to find out the square root of perfect square numbers, which is 4 digits. So it might look complicating right now, but once the students come into practice, whenever we just fold up our hands and then we try to think and we try to say these the square roots without performing much of a written calculation, and we take the help of our mental ability, the students will slowly come to par with this, because this is a technique which might seem difficult at the first, but after you master it, after the students master it, I think it'll be hardly 5 seconds or something like that to tell the square root of any 4 digit perfect square number. So this is the square root of 2209, which is 4 and 7, 47. Since 4 into 5, 20 was greater, sorry, 20 was lesser than 22, so 22 was greater. So since 22 is greater, then we choose the bigger number, which is 47. So this is how we find out the square root of perfect square number, which is of 4 digits. So now, likewise, using the same technique, we can find out the square of a 5 digit perfect square number as well. So for that, we need to take one number, let's say 11881. Okay, so we start making pairs from the left hand side or the unit place, but to make pairs, we need two elements, right? But when we take two elements from the right, there is three elements which remain in the left hand side of that, right? So we take two elements as pair from the right, and three elements we leave it. Okay, 118 we leave it in the left hand side, and 81 is the number that we pair on the right hand side. So while doing so, you look at this table again. So when you square 1, you are going to get 1, or when you square 9, you are going to get 81, which ends up with 1. So I'm pretty sure the last digit is either going to be 1 or going to be 9, right? So this is the thing we already know from the previous concept as well. So the last digit is either going to be 1 or 9. So to find out if the number is 1 or 9, or to find out the first digit of the square root, we use the same technique that we used. So 118. So 118 is a number which is greater than 100, right? It's greater than 100, but it is obviously smaller than 121, because 121 is the square of 11. So the square of 11 is not written here, but when student master the uh, squares up to 99, for example, if the students master the previous presentation that I just gave, the previous slide, and are able to understand or know the how to find out the square root of perfect 4 digit perfect square numbers, then they are going to be able to interpret that 121 is the square of 11. So you do the same technique now. You fit in 118 between 100 and 121, and 100 and 121. So you always choose the smaller number, which is 1010. right? Once you're going to choose the number which is 100, and the square root of that number 100 is 10. So the first digit is, the first two numbers are 1010, but we are not sure if it's 101 or 109, right? It might be 101 also, it might be 109 also. Now we need to finalize that, we need to fix that. So to do that, you multiply that 10 with one greater number. So 10 is already there in your screen, which is coded in red. So multiply 10 with 11. So 10 into 11 is 110, but still 118 that we have paired in red. In the second step, 118 is greater than 110, right? So we choose the greater number, which is 9. So first two digits are 1010, and the last digit is 9. So the square root of 11881 is 109, which is 109. So this is how you can find out the square root of numbers which are 5 digits. So if you continue this process, if students can master this process, uh, the possibilities of knowing the square root of huge numbers is also not far away from us. So these are the these are the idea on how to find out the square and the square root. Now moving on to the next section where we deal with cube numbers and cube roots. So to find out cube numbers, cube of the numbers with that start with 1. So uh, I have just channelized how to find out cubes into 4 different categories. Okay, because each number will have a specific technique which we can apply on. So if we apply a different technique for a different number, it'll be easier for us to calculate, and it'll be faster as well. So I will like to take 12 for now. And this type is actually for the numbers who which start with 1. Okay, whose first digit is 1. So it's like 12, 13, 14, and 19, so on. Okay, those kind of numbers we are going to take into consideration. So let's choose 12 for now. So I'll take you to this table over here. The first step is choose the number 12. It's already done. So in the second step, you can see, look at step 2. I kept 1 and then 2, right? And after that, there are 2 columns which read 4 and 8, right? So first of all, we write 1, okay? Then we write 2. That is actually the exact same number. And then in the two spots just after that, we write down 2 square and 2 cube, just on the right of 2. So 1 is as it is, 2 is as it is, 2 square becomes 4, and then 2 cube becomes 8. So this is step number 2, right? And in step number 3, the end numbers are to be written as it is. Okay, 1 and 8 are the end numbers. You can see step number 2, which is coded in blue, right? So 1 and 8 are kept as it is, but the numbers which are in the middle, that is 2 and 4, are now doubled, right? Are now doubled. So 4 is 4 times 2 is 8, and 2 times 2 is 4. So that is written in step 3 and just below it. So now the last step tells us to just add those numbers, and we add from the unit place. So 8 is as it is. 4 plus 8 is 12. 12 is 12, and 2, we write down 2 over here and carry 1 over. And when we carry 1 over, 1 plus 2 plus 4 becomes 7. And lastly, in the thousandth place, there is 1. So we can say that the cube of 12 is 1728 by this process. So likewise, you will be able to find out the cube of numbers that start with 1. You can do this for every number that start with 1. So 1, 2, 12, right? And after that, the square of 2 and the cube of 2, and you leave the end numbers as it is, and the number which are in the middle, you just double them and then add from the unit place. So likewise, you can find out the squares of numbers that start with 1. So moving on to how to find the cube of numbers that end with 1. So to do that, I think you'll be finding this easy, because the steps that are predominantly in use are actually more or less the same. So we choose 21 for now. So we are trying to do numbers which are actually ending with 1 in this step, in this type. So 21. So as we wrote down the number 12 in the last question as 1, 2, and the square of 2, and then the cube of 2, right? So now we are going to do the exactly opposite thing. 1 is to be written on the unit place, and then in the 10th place 2 is to be written, and in the 100th and in the 1000th place we write down square of 2 and cube of 2 respectively. So for example, you can see this step number 2, where the numbers are coded in blue. So on the rightmost side, or in the unit place of the number in step number 2, there is 1, and then we have 2, so that 21 is actually exactly kept over there. And on the right of 2, we have square of 2, and on the right of 4, which is square of 2, that is cube of 2, which is 8. So we do that. We do not touch the end numbers like we talked about in the last slide as well. And the middle two numbers, that is 4 and 2, we double that and exactly put it in step number 3. Exactly, double of 4 is 8 and double of 2 is 4. And now you add the numbers, but add from the unit place. So 1 as it is, 2 plus 4 is 6, 4 plus 8 is 12, but we write down 2 and carry 1 over, and 1 plus 8 is 9. So we can say the cube of 21 is 9261. Okay, so moving on to the next type. Now here we deal with numbers which has the first and this same first and the second digits. So we are talking about numbers like, let's say, 22. Okay, so numbers 22. So this is rather easy because for this, I think you can see this. Look at step number 2. In all 4 places now, when the numbers are repeated, we keep the cubes of 2 at every place. For example, 2 cube, 2 cube, 2 cube, 2 cubes. All makes 8, right? So 8, 8, 8, 8 coded with blue. I think you can see that, right? And again, we do the same thing. Just leave the first and the last digit, and whatever digit is in the middle, you just double it. So double of 8 is 16, and we do that for all the for both the numbers in the middle. So 8 twos are 16, 8 twos are again 16. So now you can start adding from the rightmost side. 8 as it is, 8 plus 16 is 24, so we put 4 down and we carry 2 over. So 2 plus 8 plus 16 becomes 26. Again, we write down 6 and carry 2 over, and 2 plus 8 becomes 10. Now we do not have to carry over because we do not have further addition, so we write down 1010. So the square of 22 is 10648. 10,648 is the cube of 22. So likewise, we can find out the cube of number which cube of numbers which have the same first and the last digits. And now lastly, in the cube of numbers that have totally different digits, we can use this technique. So let's say 23. 2 and 3 do not have any relation between them. The first digit is 2 and the last one is 3. So for this, let's go into the table. I'll tell you what we are going to do. So first of all, on the 1000th place, or in the on the right, on the leftmost side, you write down cube of 2, the cube of the first number, that is 2. We have the number 23, right? So cube of 2 is to be written on the leftmost side, and the cube of 3 is to be written on the rightmost side. Okay, so 8 and 27, it fits there perfectly. And now in the middle two, okay, in the middle two numbers that we have to fill in, so write down, first of all, square 2 and multiply that with 3. So square the first number and multiply it with the second number and write down over there. 2 square is 4. 4 into 3 is 12. So we write down 12 after 8, right? And again, you can square 3 and multiply it with 2 and write down just beside it. So 3 square is 9 and 9 into 2 is 18. So you fit 18 just on the left of 27 or just on the right of 12. So the step 2, which is coded in blue, you can see it's 8, 12, 18, and 27 respectively. Okay, so you do the same thing again. You leave the last the end numbers, that is the leftmost and the rightmost number, that is 8 and 27, you leave it, and whichever numbers are there in the middle is actually doubled, right? It's doubled. 12, it becomes 24. 12 twos are 24. 18 twos are 36, right? So now after you do that, you add the numbers from the unit place. So 27, we are only supposed to keep one digit or unit digit over there, and others are carried over. I think you have seen in the previous 4 slides as well. So 27, from 27 you keep 7, carry that 2 over. So if you add 2, 18 and 36, it becomes 56, right? So you keep 6 and you carry 5 over. So now again you add 5, 12 and 24, right? If you add that, it will become 41. You keep 1, you carry 4 over, and 4 plus 8 will give you 12, and there's no further addition, so we can write down 12 as it is. So you can say that the cube of 23 is 12167. So this is how you can cube the numbers which do not have any link between their digits. So these are the 4 cases where you can find out the cubes of numbers by using the mental mathematics approach. And lastly, now this is the last one for my presentation for the day. So you can find out cube root of any number, any perfect cube number. You can find out in seconds. I'm pretty sure if you look at after this slide, you'll be able to tell me the cube root of any numbers which are perfect cube in less than 5 seconds. So please have a look at this table first. So first of all, let's choose a number. Let's say 39304. This is a number which is a perfect cube. So whenever you look at this number, you have to look at that table as well. So just look at the numbers. I have written down 1 to 9 and the cubes of 1 to 9 in the middle, in the second column. So 1 cube is 1, 2 cube 8, 3 cube 27, 4 cube 64, and so on up to 9 cube, which is 729. So if you look at this, it is a little different from the squares, because if you cube 1, you are going to get 1 as the last digit, and no other number is going to give you that. So 1 cube is 1, and no other number is going to give you 1 at the end. Okay, but while squaring, I think you saw in the square section as well, whenever you squared a number, let's say 1, you get n digit as 1, and whenever you squared 9, you also got 81, which would end up with 1, right? So that confusion is out of the door here, because we do not have such kind of confusion. 1 square will give you 1, which is the last digit. 2 cube will give you 8, which is again the only digit that ends with 8. 3 cube is 27, so it ends with 7. 4 cube is 64, 4 ends with 4, right? So likewise, there are no other numbers which contradicts the last digit rule. Okay, so 1, if you have a number which ends with 1, you are going to write down the last digit as 1, because there is no other option. So whenever you cube a number that ends with 9, you are going to get a last digit which will be 9. So likewise, if you look at this table properly, whenever you cube 1, it ends with 1. Cube 2 ends with 8. Cube 3 ends with 7. Cube 4, 5, 6, it ends with 4, 5, 6. And then 7 ends with 3, 8 ends with 2, and 9 ends with 9 itself. So if you look at this number, if you know this rule, if you are well awakened of this rule, then you can now find out the cube root in seconds. So let's say, let's look at the number. The number is 39304. Okay, so what you're going to do is, first of all, you got to write down, let's say, okay, so let's write down the number 39304, right? So this 39304, you have to just choose the number. Look at the last digit. The last digit is 4, right? So as I already told you in the previous slide, whenever this last digit is 4 over here, I think I can use a pointer here. Okay, so you can see this, and this last digit is 4, right? So this last digit is 4. Now, no number will give the last digit 4 until and unless the number is 4. So 4 cube is 64, right? So this last digit is 4. So you can be very sure that the last digit of this cube root will also be 4. So now after you do this, let's see here. Let me use this pen here. Okay, so after you do this, you just can cross out all these 3 numbers. You do not need these 3 numbers now. After you've done this and known the last digit is already 4. We already know this last digit is 4. The cube root will also have number which is 4, right? So we do not need any of these last 3 digits. So you can just wipe this off. You do not need this, right? So now the remaining 2 digits is 39. It's 3939. So now you have to find this 39 amongst the cubes. So 39 should be somewhere in between 27, right? It's somewhere in between this 27 and 64. So as I told you in the square root section as well, this 39 should be somewhere over here, right? This 3 and 9 should be somewhere over here between 27 and 64. So now always choose the lower one. I told you in the square root section as well. So you choose 27, and not only 27, you get the square, you get the cube root of 27, which is 3. So your first digit is 3. Your first digit is 3 because 39 lies between 27 and 64. You always choose the lower one, which is 27, and you get 3. And then looking at the last digit, you can always choose the last digit of the cube root, because cube root with ending with a perfect cube number ending with 4 will have the last digit as 4. So the number is 3, 4, 34, and there cannot be any other number which will contradict this. So this is how you can find out the cube root of any perfect cube number. So more than this explaining the steps, I just showed you hands-on. So this is the cube root of 39304, which is 34. Okay, so with this, I come to the end of my presentation. I hope that I was not very fast, because I couldn't explain everything very slowly. So if you all didn't understand something, maybe I can leave my email or something like that, my contact number or email, and I can just explain this whenever you all need it to be explained. Thank you so much. Have a very good day, everyone.
Thank you, Siddhartha sir, for your presentation. It was very interesting, and I did find some of this step very complicated, but it's still like if the students can do slowly, like they can definitely be able to do that. Thank you, Siddhartha sir. Since we did not have, we had only one presentation. Siddhartha sir elaborated his presentation to a longer time period, and I think all the participants did learn something from him. So Bino sir is saying, enjoyed your presentation, very insightful presentation. Thank you, Siddhartha sir. So now, if there is any question from any participants, you are free to write it down on the chat box, or you can raise your hand and ask on your own. Is there any question? Are there any questions? So, wonderful, so good. Thank you so much. So, Daniel is saying that if others do not have question, I just have a question for you, Siddhartha sir. So I saw that you presented, you have the square roots. Like, did you come up with your own, like how to do all this, or like you took some references? I was so curious to know about how did you come up with this idea of doing the squares and the square roots and all those, sir.
Okay, thank you so much, Roshni ma'am, for the question. So actually, I've been dealing with kids of grade 5 to 6, 7, and grades 5, 6, 7, and so on, from the previous maybe 6, 7 years. I've been conducting a maths club in my school. So to in order to help the students, I've done a lot of research on the mental mathematics approaches. So this is a accumulation of all the researches that I've done, and a few ideas that I have been able to inculcate in myself, and I've tried and tested that throughout the years to come up with this, ma'am.
Thank you, Sitaza sir. So you have been doing really intensive work to help the kids out. So my next question is, how do the student react when you teach all this? Like, are they wow, or are they, there are too many steps to do, I would better follow the traditional one? Which one do they prefer?
Yes, ma'am. Okay, thank you so much. So basically, we do not do all of this in a day. So we take time. We just meet up in a week. Okay, so every Tuesdays and Thursdays I have certain group of students with me. So I just stick one concept to them in a day. So I do it slow. So I have just brought out about 3 4 months of work accumulated today. So whenever we do this, the students are able to just put their hands by their sides, and without using pen and pencil, they are able to do. So whenever I explain the topics or the content with you all, so I just went a little bit fast because this presentation has a time limit. So whenever I do it with the students, we do it hands on, we do it by taking time. So the students are actually intrigued. So I found this very useful. That's why I'm continuing it for from the past about 6 7 years.
Thank you, Siddhartha sir. I see your passion towards math and how you're dealing with the kids, and your passion towards teaching as well. Thank you, Siddhartha sir. So, if anyone has any question, okay. If and no, we do not have any question, since we our second presenter is not there, or the first presenter was not there. I would like to thank Siddhartha sir and thank all the participants for your participation, and thank you, Siddhartha sir, for your wonderful presentation. Have a good evening, good rest of the evening then. If no one has any question, otherwise we still have some time. We can hang in here. Anyone has any question? Okay. So thank you, Siddhartha sir, and good night, everyone.
Thank
I
you,
end
Jen.
the presentation today here. Thank you. Thank you for your presentation.